If x is approaching infinity, guys, if it's for limits, we're looking at end behavior. Cool or not cool? So what are you going to know about end behavior is rates of growth. What grows faster? So the slowest are logs. And I put it in order here. You go left to right. Log base x, log base 9, ln x, log base 2. Ln x is the same thing as log base e. And so these grow faster, these grow slower. And it's evidence if I were to take out my calculator. So let me take out my calculator. And if I were to type, come on, buddy, come on. Go faster. Come on. All right. If I were to type, I'll show you how to get the log base in here. So let's start with just a regular log x. And then let's get a log base 9. So I'm going to push math and scroll down until I see something that says log base. And I'll put a 9 here with an x on it. Sorry, guys. And then I'll do natural log x, which is the same thing as log base e. And then the last, I'll do a log base 2. Log math, log base 2, and then put an x. And then hopefully I still have the second table set an auto. Nope, I don't. I meant to say ask. And okay, now here we go. I'm just going to make x really large. So obviously at 1, all of them should say 0 because all of them intersect 1, 0. And they do. All of them say 0. If I put 10, the log base 10 will be 1. But then check it out. Look at the others. 1.048, 2.3. It's growing. These are growing at a faster rate. If I put 100, this one's going to say 10, or sorry, 2, because 10 squared is 100. 2.09, 4.6, 6.6. They're growing really slow, but they're still growing. So these are the slowest, the ones that grow the slowest. See how the y values are still small, even though x is already at 1,000? But it's still growing. It's just growing at a very slow rate. Cool? All right, and then what grows faster? What grows faster than logs? Powers. And I put it here in order. X, x squared, x cubed, x to the fourth. So I'm going to make an example real fast. So if you have log, if I have limit as x approaches infinity, and I have log base 2 of x over x, what's growing faster, the numerator or the denominator? The denominator, because the denominator is growing faster, this thing is approaching 0. And that's the whole logic behind it. And I just wanted just to get you guys experience. What grows faster than powers? Exponentials. Is there anything that grows faster than exponentials? There is. Factorials. So if I have something like x factorial, that grows faster. But we're not going to talk about those just yet because that's beyond the scope of the sequence of this course. So we don't have to worry about it. And I don't think Delta Math asks you questions like that. If they do, let me know. We'll talk about it. Okay. So you have the background knowledge to do a question like this. We've done it. You've actually done it. Maybe just not this exact style, but you've done it. So notice that x is approaching infinity. You should be thinking end behavior. Are we cool? So you're looking for the highest degree in the numerator, and I see that the highest degree is this one right here. But notice that I have a cube root. Do you guys notice that? So I'm going to rewrite this like this. Limit as x approaches infinity. What's the cube root of 64? Do you guys know by chance? 4. Yeah, 4 times 4 is 16, and 16 times 4 is 64. So this is going to be 4x to the 11th divided by 3. Because 11 doesn't go perfectly into 3. Divided by, and the highest degree in the denominator is 4x to the 4th. Are we okay so far? Okay, now before you give me an answer, what is larger? What is growing faster, the numerator or the denominator? The denominator, just barely. This is x to the power 4th. 3 goes into 11 3 times, right? 3, 6, 9, 10, 11. So this is 3 2/3 power, and this is to the power 4. So the denominator is still growing faster. So because the denominator is growing faster, this is going to be 0. How do we feel? Awesome. All right, last one. Well, actually, 2 more, and then we've got to go to the next one. So this is approaching infinity. Remember, ln's grow really slow, right? So this is what the ocean is in the numerator. So I'm going to write limit as x approaches infinity of x to the 8th over negative x to the power 48. And you can, if you want, reduce that, but I would just leave it like this, and then I would say, what's growing faster as x approaches infinity? The numerator or the denominator? The denominator. So this is, again, 0. As long as the denominator grows faster than the numerator, it's always going to be 0. Cool or not cool? All right, last one before we hit the next one. So I have an exponential, and I have a logarithmic. Which one's ocean? Which one's spit? The ocean is which one? The exponential. Limit as x approaches to infinity. YouTube, in case you're wondering what's ocean and spit. If you spit into the ocean, does the ocean rise? That's where that came from. 5 to the power x over, and then which one's higher? Which one has the highest degree down here? It does not matter what the power is. As x approaches infinity, eventually the exponential will grow faster than a power. It doesn't matter if it's to the power 1,000. Are we clear? So because x is approaching infinity, it does not matter what power it is. The exponential will eventually grow faster than the power one. Yay? Because the exponential grows faster than the power, this one does not converge to any number. You can either write does not exist or the behavior. So this is positive infinity because 5 to the power x looks like this. And this is, well, 6 to the power 56. It's like kind of like quadratic, but very fast, but in the negative direction. So positive divided by negative is a negative. So there's going to be negative what? Negative infinity. How do we feel? Okay. Turn the page. All right. So here's the connection between limits and the next unit, rates of change, instantaneous rates of change. I want a tangent line. I need two things for a tangent line. What and what? Point and a slope. So if I want that tangent line at x squared plus 1 at x equals 1, let's get our point. I'm going to plug in a 1. 1 comma, what's 1 squared? 1 plus 1. So there's my point. Now I need to get a slope. So here's how you find your slope. The slope is equal to the limit, and we're using h as delta x. As h approaches 0, of f of 1 plus h minus f of 1 all over h. And that's what we did yesterday or 2 days ago, right? Where f of, don't get confused, f of x is simply the same expression, x squared plus 1. Yay or nay? We already know f of 1. F of 1 is 2. I need to figure out on the side, go get f of 1 plus h. So here we go. F of 1 plus h is equal to parenthesis 1 plus h, close it squared, plus 1. Have I confused anyone on how I got that expression? Ask me, guys, because I can't read minds. Okay, I'm looking at everyone, and everyone's not in their head, so we're good. I'm going to expand the 1 plus h squared, guys. 1 times 1? 1. 1 times h? 1h. But you're going to have two of those, so it's going to be 2h plus h times h squared, and then I'm going to go plus 1. Now I'm going to combine like terms. So f of 1 plus h is equal to 2 plus 2h plus h squared. Are we okay? All right, I come back, and I'm going to write m equals limit as h approaches 0, and I'm going to write this expression first. I'm going to write 2 plus 2h plus h squared minus 2. All this is over h. Are we okay? Nothing crazy, right? All right, the 2's zero out, those 2's there. Now that I've zeroed out those 2's, can I factor out an h? Yes, I'm going to factor out here just because I want to show my fans all the work here. And you guys, 2 plus h all over h. When I say fans, I mean my YouTube fans. So, hello, YouTube. Give it a thumbs up, please. H's cancel out. What is h approaching again? 0, so this is just 2. Yeah, you're good. All right, that's my slope. I got my point. So here's my tangent. Y minus 2 equals 2 parenthesis x minus 1. Let's not get this confused. That 2 is this 2, and this y value is that 2. Yeah, next time I'll choose values that are not the same. I wasn't thinking, I just chose a simple one. Are we okay there? All right, there's my tangent. If I were to plot y equals x squared plus 1 and this expression, let's see what that number is. Y minus 2 equals 2x minus 2 plus 2 plus 2. Oh, it's just y equals 2x. So y equals 2x is my tangent. And if I go, so here's my calculator. I'm going to clear. And if I go x squared plus 1, and what was the other one? Just 2x. And let me make it a square window, y squared. Yeah, that looks like a tangent. Boom, right there at 1. Cool or not cool? All right. All right, here's the question that is interesting to me, that I hope that you guys are interested also. So Mr. Winners last year could not give you questions like this because they required calculus. So, oh, by the way, real quick, before I go into this question, because I want to make sure that you guys know, I could have gotten this slope with my calculator, right? How could I have gotten that slope? I can just choose numbers really close. Choose numbers or x values really close to x equals 2. So what do I mean? Watch, check it out. I actually have, watch, here's what I mean, guys. See how you have y equals x squared plus 1 right here? I could have done this. I could have said, well, I'm going to go alpha y equals, enter, and I'm going to type in alpha trace y1, and I'm going to go, let's see, 2 plus x, or it was at 1, sorry. 1 plus x, close it, minus alpha trace y1, close it at 1, all divided by x. So the x is like my h, right? And I'm just going to make x approach 0. So I'm going to go second table. Where's my table? And let me delete. Check it out. I could have gone 0.1, 0.01. 0.001. Hey, how come I'm not getting 2? Oh, because I didn't, did I not do it? X squared plus 1. No, it should have been 2. Oh, because I haven't, man, I'm so, okay, sorry guys. I plotted this in here instead of in the Y. Dang it. I wonder, do they have a cut paste feature? Right here, that's what I meant to do it right here. Alpha trace Y1, and I'll show you another way. I'll show you 2 different ways. Or 3 different ways. 1 plus x minus alpha trace y1 at 1 at x. Okay. Sorry guys, here we go. All right, check it out guys. 0.1, 0.01, 0.001. Look what's happening to my y2. Do you guys see that? 0.0001, enter. So do you guys see how we're getting closer and closer to the value of 2? Okay, and by the way, that's not the original one that I wanted to show you guys. So what if you don't want to do any of this fancy stuff? You could have just done this as well. You could have gone f of 2.01 minus f of 2 over 2.01 minus 2. So check it out. This is y2 minus y1 over x2 minus x1. Do you guys see that? And this will be a number really close to 2. Because that's what slope is. I'm getting really close to... I keep making mistakes. At what x value was I looking at? At 1, right? 1. Keep making mistakes. Sorry, guys. It's been a day. So check it out. If I just go to my home screen here, and I have all these, if I confuse you guys, I'm sorry. Alpha y equals, all I'm doing is y2 minus y1. Alpha trace, enter, I'm going to make it really close. Parenthesis, 1.001 minus alpha trace y1 of 1 all over 1.001 minus 1. Look what happens when I push enter. Because I'm just getting really, really close to it. So that's just my slope. Does that make sense about why this is slope? Of course, that's secant slope. The closer I get to 1, the better this will get closer to 2. right? 1.00001 minus y of 1 over 1.00001 minus 1. It'll get closer to 2. Cool or not cool? Okay. Finally, and I'll try not to make any mistakes on this one because it is a super important one. Did that make sense, Flotus, or no? No? Okay. Sorry, Miss, you sounded depressed. I'm sorry. Okay. Okay. Did it make sense? Okay. All right, here we go. Hype yourself up. Hi. Okay. That sounded like I was in the restroom, right? Okay, sorry. All right, here we go. All right, focus, guys, focus. All right, the distance s in meters traveled by an object after t seconds, okay, guys, is given by the function s of t equals 3 to the power t minus 1. So this tells me what position I am at. Tells me position. Right? If I plug in s of 0 is going to give me 0, so I haven't traveled anywhere. And that's what it says. For you physics peeps, since c is greater than or equal to 0, this will make s of t is greater than or equal to 0. Since s of t is strictly increasing function, distance traveled is the same as displacement. Hence, the word velocity and speed can be interchanged without penalty. Cool, right? All that means is this. I'm at position 0, at 0, and this is a strictly increasing function. So if I get like s of a equals 10, that is the same as distance traveled or the same as displacement. Cool or not cool? Yeah, don't worry. It's just distance traveled. You're only traveling in one direction. All right, determine the average velocity over the first 2 seconds from 0 to 2. Well, all I do is position final minus position initial divided by the change in time. That's all you're doing. So I'm just going to go s of 2 minus s of 0 divided by 2 minus 0. Was that hard? No. So I'm just going to go 3 squared minus 1. That's what s of 2 is. Minus 3, 0 minus 1, which is just 0 all over 2. So let's see what this is. 3 squared is 9. 9 minus 1 is 8. And I guess I'll write it. 8 minus 3 to the power 0 is 1. 1 minus 1 is 0. And that's divided by 2. What's 8 divided by 2? So my average speed is 4, and I need units, meters per second. Are we okay? All right. Letter B. This is the important one. Yes, but this one's going to require some either something. You'll see right now. Estimate the instantaneous velocity at t equals 2. Indicate your method. Okay, I want the instantaneous velocity. What am I going to do? What do I do? What do I do? Calculate. How do I calculate the rate of change? The instantaneous rate of change.
What are we using right now?
T equals s of t. 3 to the power t minus 1. And I want my rate of change at exactly t equals 2 seconds. My instantaneous velocity. How do I do that? No, that's IVT. We're not doing anything with IVT. Don't guess. Well, I mean, guess, but an educated guess. Is the change in velocity. Velocity is the change in distance divided by time. But I want the instantaneous rate of change. So look at your notes from yesterday on how I did that. You know how to do this, right? No, yes, you do.
So t is equal to 2. Would you plug in?
I mean, that's part of it, but this is not all of it. 3 squared is not. I'm doing the slope formula thing, yeah. What is it? Well, but first I got to write something in the front because I want instantaneous. Limit. H approaches 0. Okay, what's my y2? That's s of 2. Okay. S2 plus h minus h. S of h? S of 2. This is like final position. This is like initial. And all this is divided by what? H. All right. Here's how this looks like now. Limit as H approaches 0 of... No, I'm not trying to trick you. I need to know what S of 2 plus H is. So what is my... Just give me my expression for S of 2 plus H. What is that? 3 parenthesis. Okay. Yes, where the parentheses is an exponent, right? Okay, so here it is. 3 parentheses 2 plus H, close it, minus 1. That is S of 2 plus H. Minus, what was S of 2? 8. All over H. This is different from the other questions you've done, because all the other questions you've done, you've been able to do algebra where you cancel out the H. With this one, is there anything? I mean, I guess if you're really, really, really good, you can get that H out. But with what we know right now, can we solve this one right here with just analytic calculations? No, we have to use what? You have a tool. It's in front of you. Yeah, it starts with a C. You have to use your calculator, and you got to be smart. So this is, guys, this is, focus. This is why you got to know how to use that tool like no one's business. So I'm going to plug this into my calculator, and there's many ways to do it. I'm going to plug this into my Y1, and instead of an H, I'm going to put a X in my calculator. So here we go. Take out your calculator. Everyone try this out. And this is not the only way. There's many ways. This is not the only way. There's many ways on a calculator. I'm going to put a fraction feature first. So does everyone know how to get that fraction feature in? Make sure you try, guys. All right. Okay. I haven't done anything yet. On Y1, I just put the fraction feature. All right, I'm going to put 3 to the power 2 plus H? So 3, then put a caret, and then put 2 plus X. And then push to the right so you can go back down. And then what was it? Minus what? So minus 8, all divided by X. So does everyone have it looking like that? Oh. Okay, gotcha. See, good thing you guys told me. So second insert and then parenthesis. So there's my open parenthesis. And let me get down here, minus 1. And then close parenthesis and then minus 8. If I wanted to, you could have said minus 9, but that's fine. I just put second insert. You can start from scratch if you can't do that. Second and then the INS button where the delete button is. And you can answer stuff like that.
Whoa, I've been having to delete it all.
Yeah, but now we know. See, okay, yeah. See, for Christmas, guys, see if your parents can get you a calculator for Christmas. Kind of joking, but kind of being serious. That's what I would want. Okay. Yeah, I know it is pretty pricey, but it's an investment. You're going to be using it for the next 4 or 5 years. All right, here we go. Are we okay with this right here? All right. Okay. Next, go to table set. So I'm going to push second table set. And you should see this screen here. Second table set is the window button. Where it says independent, put ask. Did you guys put that? Yes. Okay. Yeah, a second window. Second, when I say table set, it's because it's going to the blue one. Second table set. All right, now I'm going to go to a table. So push second and then the graph button, the table. And it should be blank. I just made mine blank. Cool or not cool? I'm making the X. Remember, X is like H. I'm making that approach 0. So I'm going to start with 1. Then I'm going to start with 0.1. Then I'm going to go with 0.01. And I'm looking to see if I'm approaching a specific number. 0.001 is still changing too fast for me. Okay, now it's getting where it's not changing as much. 0.0001. 0.00001. I don't know if I 1, 2, 3. Yeah, that's 5. See? So that e to the negative 5 means that there's 4 zeros in front of that 1, guys. 0.00001. All right, I notice now that this is slowing down. Like the rate of change of this is slowing down. Like see how it was 18, then 10.451, then 9.942, then 9.892, 9.888, 9.887, 9.887. So I'm gonna stop right here. Do you guys see that? So I'm gonna truncate it. 9.887, and then give me digits. Give me units. Meters per second. This is not the only way to do it. You could have said, Chav, I don't know that. I just know this much. You could have said this. You see this time? You could have said, I'm just going to get really, really close to it. I'm going to choose two numbers really close to 2. So give me a number really close to 2. Oh, to the right of 2. 2.00001 minus s of 2 over 2.00001 minus 2. I hope that I got the same number of digits. 1, 2, 3, 4. You could have done that, and I bet you we would get the same thing. Do you know what this is? This is just y2 minus y1 over x2 minus x1, right? I'm just zooming in really close, and I'm getting that rate of change for that secant line really close to the tangent. Do you guys see what I'm doing? And I'll check it out. I already have it in y1, so I don't have to. Oh, I don't have it in y1. What was my equation? It was 3 to the power x minus 1. Okay, I have it in y2. Remember that. It's in y2, not in y1. So I go to my home screen, and here's what I'm going to do. Alpha trace y2. I guess I should have done the fraction thing first. Let me do the fraction thing. Alpha y equals, enter. And now look, alpha trace y2. And I'm getting really close, open parenthesis, 2 point, it was at 2 seconds, right? 0.00001. How many zeros do I got? 1, 2, 3, 4, 5, 5. Minus alpha trace y2 at 2. I didn't put parentheses. 2. All right, here we go. Look at this. 2 point, and you could just put 0.0001, but I'm gonna go ahead and put this 1, 2, 3, 4, 5, 1, 0, 2, 3, 4, 5. 1, 2, 3, 4, 5. Minus 2. Look at this, guys. Ready? Look how it comes out to the same number we just got. But don't be a robot. Do you know what I just did? It's like I zoomed in and I got two numbers really close together and I used algebra. And I'm like, I'm going to find this sucker right at 2 by getting really, really close. Cool or not cool? Now, later on, Abdul Kareem, do you remember what the derivative of 3 to the power t is? Yeah, because you just did it today. Oh, because I saw you earlier. Okay, you and Percello together, together. Later on in the future, you're gonna tell me what the derivative of this is.
Okay, is it ln 3?
Yeah, but I would have preferred. Okay, I would have preferred you said 3 to the t first, but that's fine. Yes, that's it.
Oh, Zoe's here too.
And Lopez. All right, look, guys. This would have gotten you the rule. This would have got. All right, guys, focus. This would have gotten you your answer immediately. Plug in a 2 in for that t, and look. So I'm gonna go to my home screen. ln 3 times what was it? 3 squared times 3 squared. I guess I could have put 9 in there. And look at that.
Wow.
But we're not there yet. So that's why. Well, we're not there yet. You don't know how we got that ln 3 to the t. So I'm going to tell you right now, guys, there's a question on your exam that's going to require this skill. You can do it however you want. You can just say, I'm just going to zoom in really, really close and get 2 points to see what it is. Or you can do it like how we did it with a table, where we got really close to 0. We did the delta x. However you like, whatever you think. We showed you all the different tools. Cool or not cool? Okay, you're going to have one question like that on the exam. And don't worry, if you don't get it right, it's not going to kill you, but it might hurt you from getting your A on the exam, you know? Because they'll bring you down a whole letter grade. Like for the exam, not for the class.
10 point.
Well, because that's a big deal. That's like all the concepts together in one.
Okay, yeah. It's 10 20 questions.
At the moment, I have 13 questions. 10%. I can add more. I can add more.
Can you be nice when it comes to grading?
Well, see, I don't know if I can do that many in that amount of time.
Oh, yeah.